Okay, so now that you've mastered multiplication, right, and the distributive property, as I stated before, we are now going to do basically something that is done as the inverse or reverse of multiplying. Okay, and I know you've been taught PEMDAS and everything else, and you're like, oh, that's dividing. It's not quite dividing. Okay, because we don't know, we don't have like one piece. If you're doing like a division problem and you do, okay, 24 divided by 6 equals 4, and we know that because 4 times 6 is 24. We don't have the piece that we are dividing by. Okay, so it's not really dividing because there's a lot of different possibilities. It's more like factor trees or factor trees you should have done, or factor families, things like that, fact families when you were doing multiplication. There's just a little bit more to it because now we have variables. Okay, so it's not quite dividing. Okay, so we are basically going to be given an area, right, which is what we multiplied and got in the last lesson, and we having to determine what the length and the width are from that specific area. Okay, so again, we're not given one piece to divide by, right? So it's not exactly division. You're going to get into that in more upper level math where you're actually given pieces to divide by, and it's actually pretty cool. But for right now, we're doing something that is called specifically factoring. You are finding the factors, the length and the width, that multiplied to give you your area. Okay, what we're going to start off with is greatest common factor, which is something that you should have already done. Maybe not with variables, but maybe with numbers. You would have found like the greatest common factor between 2 or 3 or sometimes even more numbers. Okay, the difference now is that our greatest common factor can include variables, right? Because it's what they have in common and it's the biggest thing. So we'll do this in steps to make it easier. Start with 3 and 18, right? What is the biggest number that they both have in common that will divide into them evenly? And again, you can write out the two numbers and write out all the factors. I'm sure that was what you were taught originally to do. And you can do that. The biggest common number that will go into both 3 and 18 is 3. So the coefficient part of this is going to be 3. But now we have to look at the variable part, okay? And the variable rule, the way the variables work as far as what's a common factor, is you cannot take more out than you have, right? So this one has 1v. This one, remember, if you have v squared, that's like v times v. This one's got 2, right? So you cannot take out more than you have, right? So I can take 2 v's out of the first piece, but I can't take 2 v's out of the second piece because I only have 1 v. So the greatest amount of that variable that I can take out of both of them, that's common to both, is 1 v. Right? That's the largest amount that I can take out. So overall, my greatest common factor between these two terms is 3v. I can divide both pieces by 3v, right? And I would come out with a whole number expression. Okay. So, and by the way, when we write this, this is going to look a lot like when we were first multiplying, right? The distributive property. You would write, okay, 3v times what is going to give me my original expression, right? What would I have to multiply 3v by to get each of these two pieces, right? So if this is, and if you think about it like an area model, right? There's my two pieces of area, and basically you found your greatest common variable, or greatest common factor rather. So that's going to be your width. You have to tell me what the length is, right? What did I multiply to get there? And this should be v and a minus 6, right? To get the negative 18 times the 3, right? So this is my area. I pulled out the width, which was my greatest common factor. I'm getting my length. So it's not exactly like dividing because we at least have to come up with one piece first. All right, so let's try the next one. And again, think of it like an area, right? And I need to know the biggest thing that they have in common, their greatest common factor, so that I can pick out the width and then go and get the length. So 4x squared and negative 36x. And again, same thing as before, you can write down 4 and 36 and list all their factors. That's fine. But what we want is specifically the greatest one. 6 and then 9, I think, and I can keep going. But the biggest one can't be bigger than 4, right? Because that is my smaller of my two numbers. Okay, so 4 is my coefficient part. Make that a different color. All right, 4. And then I have 2 x's here, right? They've been multiplied, and 1 x here. So same rule. I can't take out more than I have in either one piece, and it has to be the same thing. I'm taking out the same thing. That's the common part of it between both pieces. So the common part would be an x. So my width is 4x, so now I need to find my length. 4x times another x, right, will give me 4x squared, because 4 times 1 is 4. And then 4 times negative 9, it's going to give me negative 36. And then x times basically nothing else is just going to give me another x. Okay, so we now have our width and our length. 4x times 1x minus 9 would give me 4x squared minus 36x. Very, very important in that we have to make sure we get back to our original piece, original statement. And I forgot to write it up here. The way it's written is 3v times v minus 6, exactly like when we were starting working on our distributive property, right? It has to look like that. And if we multiply it out, it should always be able to get back to our original statement, our original area, since we are working backwards. So our answer for this one should be written as 4x times x minus 9. Okay, very, very important that you take the greatest common factor first. Okay, so let's kick it up a step. So now I have an area that is made up of 4 pieces instead of 2. Okay, now you can treat these separately, but remember that you're going to get a width and a length, or a width and a length, that are 2 pieces each, and they are, they are related. They are being used all together. So we're going to write it like this, right? And if it helps, first, second, third, fourth. It's always written in that order, okay, when you're using the area model that we talk about. Okay, so same idea, same process. I need to find the GCF, right, of those 2 pieces. Same process, GCF. So between 2x squared and 6x. So the greatest common factor between 2 and 6 is just 2. And we talked about how the variables, I can't take more than I have, right, in either one piece. So my GCF as far as my variables is just an x. So you take a look at that first row, right? You're going to pull out the width. The width on that is 2x. Okay, so do the same thing you did before. What is the length going to be that works with this 2x? All right, so 2x times what, right, gives you the 2x squared. That has to be an x. And then 2x times what has to give you the 6x area. That's going to be a positive 3. Okay, so here's how this works. In order to get the other piece of the width, right, we have to make sure it actually works with this length, right? My length is x plus 3. That's already been determined. Okay, so it's actually pretty easy because we only have one piece left to fill in. What has to work? What has to multiply times x to give me 5x and has to multiply by 3 to give me 15? It has to be 5, and it has to be a positive 5. So we're done. Our answer, there's my width, and there's my length. And I have the width and the length that multiplied to get me this whole area, right? So same as before, find the GCF of that first row going across, right? That's going to give you your width, find your length, and then find the other piece of your width that works. Okay, so let's try a couple more, and then I'll give you an assignment for this. Okay, so it's written out. We're going to go ahead and try this one. So again, we need to make our area model. It's 4 pieces. I'm going to make my square. So 3x squared, and going just across, right? First, second, third piece, fourth piece. Okay, same steps. First, tell me, what is the GCF of that first row? What do they have in common as far as what can divide? 3 and 3 have a GCF of 3, and there's an x and an x squared, so I have 1x that comes out. Okay, so I have my width, find my length, so 3x times x has to give me 3x squared, and then 3x times 1 has to give me 3x. Be careful, a lot of people miss out on that 1 that you're supposed to have. Okay, same deal. What has got to be the other part of your width that works for this? X times what is going to give you x? It has to be a 1. So my width is 3x plus 1, and my length is x plus 1. Okay. One more. Okay, again, I've got 1, 2, 3, 4 pieces. Let's set up my area model. Again, we're just working backwards. 2x squared, that is a minus 6x. Make sure you're carrying your signs. A positive 1x and a negative 3. Okay, same deal. What is the GCF of that first row? So you can pull your width. What does 2x squared and negative 6x have in common? Okay, they can both be divided by a 2, highest number, and they can both have an x taken out. So you have part of your width. So what is going to be your length that goes with this? Should be an x, right? Because only have to multiply by another x to get that squared, right? And you can put a 1 there if you want. 2 times 1 is still going to be 2. That's fine. And then 2x times what is going to give me the negative 6x? Should be negative 3. Okay, so then go back and fill in. What do I got to multiply by down here for my width to get this for my area? Right, so 1x times what is going to give me x? Should just be a 1. And 1 times negative 3 is going to give me negative 3. So you can go back and multiply to make sure it works. So again, width and, messy, and length, x minus 3. All right, so that's it. This is going to be your startup assignment for finding your first part of factoring. And then you're going to go ahead and go on to your next bit where it gets just a little bit more challenging.